In this video, I'd like to show how to use the forecast techniques described in our resource, Operations Management, the 11th edition by Stevenson William. As stated by the author, there are many areas, especially in business organizations, where we can use those forecast techniques for the goal to anticipate the future and to achieve a better plan. The author also said that the concepts and techniques apply equally well to other variables. So in my example, I want to use those concepts and techniques to one of the well-known number games here in the Philippines. I'm curious, given that with a large population of data, can those forecasting techniques give a good estimate of the number chances coming out daily? Let us try to see also the potential size of the forecast error. I was able to retrieve online its history data since 2007, and it's already more than 14,300 data points available to use for this study. I assumed that the historical data I got can be utilized to make a time series forecasts. To identify the underlying behavior of the series, I chose to plot a one-year data. Based on the plot, it has a downward trend. The plot also exhibits a cyclical pattern, as defined that a cycle occurs when the data exhibit rises and falls that are not of a fixed frequency. There may be a seasonality pattern also, but there is a need for more plots and further study to make for all those data. So let's start with the naive method. As defined, naive method is a forecast for any period that equals the previous period's actual value. It also says that naive approach can be used with a stable series, with seasonal variations, or with trend. Since the data that I have apparently exhibits a trend, the forecast I computed is equal to the last value of the series minus the difference between the last two values of the series. Next, we measure the forecast errors to check the forecast accuracy. The three commonly used measures for summarizing historical errors were computed and shown: the mean absolute deviation, or the average absolute error, the mean squared error, or the average of squared errors, and the mean absolute percent error, or the average absolute percent error. The second forecast method I will show are the averaging techniques. It says that averaging techniques smooth variations in the data. Let's see if offsetting the highs and lows in the data by combining those into an average exhibit less variability than the original data. The first averaging technique is the moving average. In my example, I computed a 3-period moving average forecast until 8-period moving average in Excel. As each new actual value becomes available, the forecast is updated by adding the newest value and dropping the oldest and then recomputing the average. Consequently, the forecast moves by reflecting only the most recent values. The video here illustrates a 3-period unit until 8-period moving average forecast plotted against actual result over 144 periods. The forecast errors were also measured. The second averaging technique is the weighted moving average. As a trial and error for this averaging technique, I tried assigning equal weights to the most 10 recent values. I also computed for forecast errors. The third averaging technique is the exponential smoothing technique. Each new forecast is based on the previous forecast plus a percentage of the difference between the forecast and the actual value of the series at that point. As a trial and error, I used a smoothing constant of 50% and 30% of the forecast error. The last forecasting method I need to show is the trend adjusting exponential smoothing. In my example, I computed for the seasonal relatives using the simple average method, taking the average of three results in a day, the overall average, and the simple average relatives. The forecast was computed from multiplying the seasonal relative to the trend equation. The next thing I'd like to show you is a control chart as defined as a visual tool for monitoring forecast errors. I'm only showing one control chart for the forecast errors generated from using the naive method. Based on the chart, all errors are within the control limits. However, it seems exhibiting a cycle and non-center data. I also computed for the tracking signal method. As a conclusion to this application, these forecast techniques are definitely relevant to many ways, but for the chosen data I have, there is a need for advanced study to pull off those forecasts. There is a need to make more advanced forecast error monitoring. So that's it for this video. Thank you for watching.